My question was, question number 21. If a curve with a radius of 88 meters is perfectly banked for a car traveling 75 kilometers per hour, what must be the coefficient of static friction for a car not to skid when traveling at 95 kilometers per hour? Okay, so first let's draw out what's happening here. Now it says that the car is at a curve that is perfectly banked, which means that the car is at an angle like this. Here's the car. There it is. And the car has a couple of forces acting on it. You have weight going down like this. And you have the normal force coming like this because the car is at an angle. Now, this is the angle of the incline, but the acceleration of the car is going horizontally. So we have that the acceleration goes this way, which means our axes are like this. So almost like that. The dotted lines are axes, which means that the gravity is normal, but the normal force is on a weight is on a slanted angle. So if we say that this angle here is theta, then we have that the y, this is fny, which is fn times the cosine of theta, sorry. Then we have that this is the x, which is right here, this is the x, which is fn times the sine of theta, because this is equivalent to this. So therefore, we can write Newton's second law right now, which is the net force on the x-axis equals mass times acceleration, and the net force on the y-axis equals mass times acceleration of the y. So on the x-axis, our only force is the x component of the normal force. So Fn times the sine of theta equals the acceleration of the x, which is the mass times the velocity squared over the radius. Now we know our velocity squared and the radius, so this would be equal to mass times 75 squared, which is our velocity, over the radius, which is 88. Now, on the y-axis, there is no acceleration, but we do have two forces at work. The y component of normal force and gravity. So we have that the y component of normal force, which is Fn times the cosine of theta minus gravity equals m times 0. So we can rewrite this as Fn cosine theta equals gravity, which is 9.8 times the mass of the car. So now that we know what weight equals here, which is 9.8 times the mass, we can rewrite this to be that the normal force here equals 9.8 times the mass over the cosine of theta. Right there. Now if we bring that back up to here, this equation becomes a lot more simple. Because if we plug what we just solved Fn to be back in, we get that 9.8m times the tangent of theta. In case you're wondering where the tangent of theta came from, we get from the sine of theta divided by the cosine of theta. And we get that to be equal 75 squared over 88, which is our original velocity divided by our radius. So now, if we simplify this a little bit more, I forgot to put an m in here. The m's cancel out here. And now if you compute all these numbers, you get that the tangent of theta equals 6.522. Now all you have to do is take the inverse tangent of 6.522, which is really just a ratio between the sine and the cosine, and then you get that theta equals 81.28 degrees. Now that we have theta, we can go back to the original question and find out what the coefficient of static friction will be for a car not to skid when traveling up that same ramp banked at 81.28 degrees for it not to skid. Okay, so this free body diagram is a little bit more complicated. It's the same basic setup where we have the car on an angle. This is the car. We still have our normal force at an angle. Still have our weight going straight down, but now we add one new force, friction. It's the friction between the wheels and the slope it's on. It's also at an angle, like the normal force. Except now we know this angle is 81.28 degrees. So now let's draw our two forces here, or the components of our two forces. First we have friction going up like this. Same as before, where we draw this axis as f of y, fny, this is theta, and fny equals fn times the cosine of theta, as you can see there. Then we have fnx, which is here, right there. Fnx equals fn times the sine of theta. This theta, once again, being the same as the incline angle. Now, we have our new force, friction. Friction is going down like this, which means that our theta is going to be going this way. This theta is equivalent to that theta. So this is the fx. Fx equals f of f times the cosine of theta, which means that this would be ffy, and ffy equals